All right, good evening and welcome to pre-calculus. So we're going to be graphing a sine and cosine function tonight. Okay, so one of the graphs that you might be something you expected to do would be y equals sine of 7x minus pi over 3. Okay, now to graph this function, and my instructions, your teacher's instructions might be something like identify at least 5 points. Okay, so identify 5 points. Okay, the kind of thing that we're looking for is like the beginning, the end of one cycle, the halfway point, and the intercepts, kind of the thing, the min and the max kind of idea. So the first thing that we have to do is like, well, we're going to have some kind of a phase shift here, right? Because that's a transformation off to the right. Okay, and then we've got some kind of a period shift going on in here. So the first thing we have to do is factor out this 7. So we're going to say this is sine of 7. And we have x minus 1. If I factor out a 7, 7 times what is going to get me back to pi over 3? So we're going to have pi over 21. But if I multiply this by 7 again, the 7 times 3 is going to cancel. We're just going to get pi over 3 again. So the actual phase shift I have here is pi over 21. Okay, and then the other thing you have to do is you have to figure out, like, well, there's something weird going on with the period here. Remember, that's 2 pi over whatever happens to be in the front of the x here. So this is 2 pi over 7. Okay, so that's another one of those formulas you have to remember. Now, what I would do at this point is I would kind of sketch in the parent function, right? So if I was just graphing a sine, we'd have 0. We would call this 2 pi over 7. What's half of that? 1 pi over 7. What's half of that? It's pi over 14. And then 3 halves, right? 3 halves of this guy right here. That's going to, or 3 halves of this thing. That's going to be 3 pi over 14. Okay, 3 halves times pi over 14 here. Okay, so that's what we'd end up with. Okay, or 3 halves times 2 pi over 7. That's actually what we do. So we would go ahead and jot in our sine here, right? And then we could jot in that as kind of our parent function. But wait, there's more. The problem with this is each one of these points has to be shifted over to the right by pi over 21. So what we're going to do next is we're going to make a little table here, and I'm going to say, well, each of these has to add pi over 21 to it. Okay, this one will be easy, pi over 21. But then we've got to get pi over 14 plus pi over 21. Okay, there's nothing we can do about this. The problem I picked is painful, so that's just the way. That's just what we have to deal with. Okay, so that's what we're on. A second here. Okay, so once we have this, we can say, okay, well, that's going to be yes, I did this out beforehand. So we're going to say, okay, well, we have to get common denominator. So this is going to be 3 pi over 42, right? We're going to say 3 over 3 plus, and I'm going to say 2 pi over 42, multiply 2 over 2. So what we did was this. Okay, in order to get common denominators. So we're going to be ending up with 2 pi plus, this should be 3, shouldn't it? 3 pi plus 2, that's going to be 5 pi over 42. Okay, and that was our midpoint. Our midpoint was pi over 7. So what we need to do is we have pi over 7 plus pi over 21. It was a little bit easier of a common denominator to get, but we're going to get 3 pi over 21, right? Multiply by 3 over 3, plus pi over 20, pi over 21, okay? And we're going to end up with 4 pi over 21, okay? Hang on to that for a moment. Next thing we're going to do is we're going to take our 3 pi over 14. That's the next point that we have to deal with here. That's 3 pi over 14. And we're going to add pi over 21 to that. Okay, and again, getting common denominators. So what we're going to do is we're going to multiply 3 over 3. Okay, so that's going to be a 9 pi over 42, 14 times 3. Okay? And this guy here, this is going to be a 2 over 2. So that's going to be plus 2 pi over 22. 21 times 2 is 42, and we end up with 11 pi over 42. Notice that some of these are in 21st, some of these are in 42nds. What I would recommend is that you should make all of these 42s. So this is pi over 21. What if we convert that to 42s? So that's going to be 2 over 2. So we have 2 pi over 42, 5 pi over 42. If I convert this one, right, to 42s, we're going to have 8 pi over 42 to 11 pi over 42. You should notice a pattern here, right? 2, 5, 8, 11. Huh, I wonder if the next one is going to be add 3. So it's going to be 14 pi over 42. Okay, we'll see what happens. Okay, so what we're going to do is we're going to have our last point here. That was, I believe that was, it's 2 pi over 7. Okay, so we have our 2 pi over 7 plus pi over 21. So what we're going to do is we're going to get common denominators again. So we've got 6 pi over 21, right? Multiply 3 over 3, plus 1 pi over 21, and that is 7 pi over 21. But what were we trying to do? We're trying to test to see if this was over 42s. So what we're going to do is we're going to multiply 2 over 2, and that's going to give us 14 pi over 42. So now we guessed that was going to be 14. Hey, look at that. We are right. So if I wanted to go ahead and graph this function now, or I wanted to graph the value, okay, we're going to have our start. Okay, which is 2 pi over 42. So we have 2 pi over 42. And my last point, right, which was 14 pi over 42. What's my middle point, right? And that was going to be 8 pi over 42. Okay, this was going to be 5 pi over 42. And this here would be 11 pi over 42. We have a plus 1, negative 1. So we go ahead and plot our points. So we can go ahead and get our full credit for graphing this thing. And of course, they're going to know we did this by hand because we've got all the crummy fractions in here. I would recommend not doing it on calculator because calculator will make all of these decimals, and your teacher will know that you used a calculator to get all these points. If that's allowed, go for it. But you know, in our trigonometry class at my school, we don't like people to use the calculators like that. So you got to do all this stuff by hand. Okay, so that's how you go ahead and graph a sine curve that has an argument of a rational expression here. Okay, so that's one way to do it. All right. So I wish you luck with that. Good luck, and you know, happy graphing. We'll see you in the next video.